Okay, for today's lesson, we will be discussing the related rates and rate of change and answering some word problems, that is the application of derivatives. So, when we do differentiation with respect to time, this is one thing that we need to remember. Differentiation with respect to time, suppose a certain variable x is changing at a given time, which is t. The expression dx over dt is called time rate or rate of change with respect to time. So we need to note that a time rate of or either be positive if the rate as increasing or negative if decreasing. So it depends now the variable that is involved have against, if it is increasing it will be positive, and it will be decreasing must be negative. So here's the step that we need to remember. Respect the quantities that change with respect to time and other important quantities as variables. Second is identify the known quantities including time rates. Third, we have write an equation that rates the quantities. Fourth is differentiate both sides of the equation with respect to time. So since we will be differentiating the equation with respect to time, so we will be using d over dt. So next is example. The radius of a circle is increasing at a rate of 2 cm per second. How fast is area changing when the radius is 8 cm? So, as we have here, known the radius is increasing at a rate of 2 cm per second. Now what we want to know is how fast the area changing with the radius is 8 cm, because as the radius of the circle increases, our area must be changes as well. So first we have r, which is the radius, and a is the area. So now we have dr over dt is equal to 2 cm per second, and r is equal to 8 cm, and the missing quantity here is the dA over dt. Okay, we have the equation now is a equal to pi r squared. So we get now the derivatives of respect to time, and since we have differentiate variable, we have a, we have r, we have to use implicit differentiation. Okay, we have here d over dt of a is equal to d over dt of pi r squared. So the derivatives of this is here. dA over dt is equal to, derivatives of this is 2 pi r of dr over dt. So since the variable we use is r, we have to put the dr over dt here, dr over dt. So whatever variable that you use, that is the one you put beside d and the numerator. That is how you imply the implicit differentiation. Next, we have to solve the dA over dt. Now to get the value, we have to solve for this one. Okay, we have 2 centimeter. Next thing that you have to do is to substitute the known values. So 2 pi, then r which is 8, and dr over dt is 2, and all you have to do is simplify that. Therefore, dA over dt is equal to 32 over 32 pi. That's why, therefore, the area of the circle is changing at a rate of 32 centimeter per second here. Here is our answer. This is the final answer here. That's why the area changing at the rate of 32 centimeter per second. Okay, that's all. Thank you.